Okay, so now you've been able to think about what differentiation was. That is when you have a complete melt of a planetary body and the thicker, denser stuff goes to the center, the lighter stuff towards the outer edge. So in this picture you can see that the iron is in the middle, the stones and the iron in between, and then the lighter stony crust is on the outside. So say this happened in the asteroid belt. We had these planetary bodies, they differentiated into all of this, and then along comes something and smacks into it, smash, and splits it all into all these pieces into smithereens. Then, if all those little chunks that came from that body start landing places, that means that we're going to find the different types of pieces. We'll have stony little chunks. We'll have some that have some metal and some crystals in them, like that middle one, my favorite kind of meteorite. And then on the right, we'll just have metal pieces. And all because these planets differentiated before. Now, ASU is doing a really cool mission. They found an asteroid up in the asteroid belt that was particularly shiny. So shiny that they're convinced that this is an asteroid that might be solid metal. So thinking in the last picture, then solid metal means it might be the core of a planet that broke apart, and that's the middle part after it differentiated. So ASU is doing a mission to the metal world. They called it Psyche. And they don't know what they're going to find when they get there. They imagine this. This is an artist conception. So we have seen how everything looks cratered that's out in space. It's getting hit by stuff all the time. Well, what if you have a metal world? It gets hit by something, another rock comes flying around, and it hits hard enough to create a crater, melt the metal gets shot up, and then it freezes in space. That's what this artist is trying to say, is maybe we're going to find some very funny structures if it's a metal planet indeed when they get there. So farther out, those are things in the asteroid belt between Mars and Jupiter. Now we're going to move way out to the Kuiper belt, and this is where leftovers also ended up, but these leftovers are the things that the outer planets are made out of. The ices, the ammonia, the methane, the water that have frozen into objects way, way out. Now look at the solar system drawing there with the planets. The blue one is Neptune. So farther out is the yellow orbit. That is Pluto. That is one of the reasons that Pluto got demoted, is it's not traveling in the flat disk of the solar system. It's traveling at an angle. So it's traveling in and around the sun, but very much off the plane. It is a Kuiper belt object. So these are called trans-Neptunian objects, and these are the biggest ones that we know about. So we look at them. Here's Pluto with its moons around it. It's not showing all the moons. It actually has more than that. So Charon, or Charon, I think they say it, is its biggest moon. But look at the one to the left of Pluto. That's Eris, and Eris actually is a larger planet than Pluto is, which is another reason that Pluto got demoted, is because it's a larger one and it didn't get to be a planet, so why should Pluto? And here is kind of a sketch of how the orbits are of these other Kuiper belt objects. See how they're not flat on the plane of the solar system there. Now we're going to talk about comets a little bit. Comets are different than asteroids because of their makeup, what they're made out of, and actually where they come from as well. Comets have always been sort of an omen to people, and people were scared of them, and sometimes astrologers back in the day were hired by the kings to watch for them because it might tell them if they're going to win a battle or not. Well, in 1910, Halley's Comet was coming around, and there was a lot of superstition about it. That's an actual photograph right there of Halley's Comet, and that is really cool. Look at the tail on that thing and how bright it is, that this old film could pick it up and make it show that much. So they knew it was coming, they could see it, and there was a lot of superstition. People are going, oh no, it's going to crash into Earth, it's going to kill each other, kill everybody. But more than that, they were thinking it was going to give off gases that would kill people on the Earth. So people took advantage of this, and they came up with comet pills. So you could buy a bottle of comet pills. When Earth passed through the tail of Halley's Comet during its 1910 approach, there was public fear that a gas discovered in the tail, cyanogen, would destroy all life on the planet, leading to people buying gas masks and anti-comet pills. So this was one of the scientists that kind of put the scare into people. Cyanogen gas would impregnate the atmosphere and possibly snuff out all life on the planet, says this Camille Flammarion. So these kind of things were published and people got scared. And if you didn't want to buy comet pills to protect yourself, there's always comet whiskey, if that's your preference in intake. But this was kind of a funny advertisement that I found in a newspaper. It says, to escape the comet, hire a submarine boat. Deadly cyanogen gas does not travel through the water, so to escape the comet, hire a submarine boat. Fill it with 3 days' edibles and drinkables and go under water tomorrow. The deeper the spot, the better. Stay under for 3 days, not even poking your nose above 1 moment. At the end of that time, if nothing happens to your submarine, the cyanogen gas in the world will have spent itself. Then, if all the people in the world have perished under the deadly gas, you can claim the world for your own. If they are not dead, perhaps you can stand the laugh. So kind of crazy stuff. So let's look at the anatomy of a comet. So we've got the core, or the nucleus there, little black dot that they're showing there. Around the nucleus we have a coma, and we also have 2 tails, and they are different from each other. So if you can picture dry ice, you probably all played with dry ice. Dry ice doesn't melt. It changes from a solid to a vapor directly. It doesn't melt in between. That's called sublimate. So these comets are like that. They're icy objects, and when they get exposed to the heat of the sun as they come in from their outer orbit towards the sun, then they start to sublimate. So they leave this misty stuff in the dust tail, and they also have some dirt in them. We call them dirty snowballs. And so the dirt and the dust and the sublimation follow the nucleus as it begins to travel around the sun, and we get a curved tail because of the motion of the nucleus going. Okay, but the ion tail is a little different. The sun has cosmic rays, it has radiation coming off of it, and it ionizes some of the material to where it's charged particles, and those particles always point directly away from the sun. So the curved tail is kind of the path that it's traveling, but the ion tail always points directly away. So here are a few other comet pictures of ones that were large that we could see with the naked eye. This is Comet Bennett West. That one you can see the 2 tails pretty well. The blue one on the bottom being the ion tail. Hale-Bopp, and if you look real closely in that one, you can also see an ion tail, the bluish just above the white center there. Another one that I don't have the name of. And there's a close-up of Halley's Comet. That's kind of a neat one because it's showing, it looks like dry ice when it's sublimating like that. This historic photograph of the black, irregularly shaped nucleus of Comet Halley was obtained by the ESA Kyoto spacecraft from a distance of about 1,000 kilometers. Pretty cool. So this is sort of an illustration so you can see how the tails are. So it's moving in from way out in the solar system. When it's way out in the solar system, it's cold out there. So out there it's not sublimating. It will just be an ice blob in space. But it's as it comes in towards the sun that it heats up that this action starts to happen. So look and notice if you draw a line from the sun through the comet straight out, that's the direction that the tail will be. Doesn't matter what position it's in, the tail's always directly away from the sun. Here's a neat picture on the left that shows you the two tails, and on the right some actual photographs that are really nice too, that show the distinction between them. And if you were to draw the tails around a comet, there may not even be a tail on the right side there, but much smaller if you were to draw it. Always pointing away from the sun. So what's a comet look like when it isn't sublimating? Like a weird shaped ice blob. We found a lot of them look a little bit like a snowman because they have a small blob and a bigger blob. That's kind of been common. This was the Rosetta mission that was sent up by ESA. And if you don't know what ESA is, it's like the NASA of Europe. It's the European Space Agency. So they sent a mission up here to orbit this particular comet. And it had two parts to it. It had a spacecraft that orbited around it, but it also had a lander. And it took some pretty cool pictures. If you look at this picture, you can see it's just spewing material out of it. The spacecraft found that the outburst had pushed away the solar wind, magnetic field from around the nucleus. Now, many years ago, they used to speculate on Earth that all the water that we have on our planet, that's kind of unusual because we don't see this much water on other planets, came here from comets. That early in the solar system formation, the comets came in and bombarded the planet and created all the water on our Earth. When the missions have gone up and taken samples of the water from these comets, they don't match. So isotopic analysis of deuterium in the water ejected by the comet shows that it's different from the water found on Earth. Thus, apparently comets like 67P did not contribute to the origin of our oceans or water in our bodies, as some scientists had thought. So it disproved that particular theory, which is the beauty of science, that we make a theory. When we find data that doesn't quite add up, we change the theories. Now we just kind of think the water outgassed from the rocks that we had on the planet. So I told you this had two parts to this particular spacecraft. One was an orbiter that followed it around, but it had a little lander that they wanted to actually land on the comet called Philae. Now Philae was released, it went down, and it had little hooks in the bottom that were supposed to grab the planet, and it didn't happen. And I'll tell you the rest of this story on the next video.